Hello, everyone. Welcome to our third webinar in a series. I'm Kevin Burkham. I am CEO of U.S. Farmers and Ranchers in Action. We are a farmer-led organization that works to champion agriculture and raise the voice of farmers and ranchers on important challenges that are facing the sector. As I mentioned, this is the third in a series of webinars on the 5 key opportunities that were identified in the potential for U.S. agriculture to be greenhouse gas negative report that was published late last year. That study was authored by an independent group of 26 leading scientists, and you're going to meet a couple of those scientists today. It was peer-reviewed by the National Academy of Sciences, and it provides evidence of what's possible for U.S. agriculture. It is possible to reduce greenhouse gas emissions, increase carbon sequestration, and improve farmer profitability. And that last piece is critical, especially now. I mentioned the 5 key opportunities for agriculture that were identified in that report. They include nitrogen fertilizer management, which was the subject of our first webinar back on April the 23rd. The second was soil carbon management, which we discussed at the second webinar on May 21st. You can view the recordings of both of those webinars on our website, usfarmersandranchers.org, and our YouTube channel as well. Today, we're discussing the third opportunity, animal protein production and management. The last 2, the crop production and yield gap and efficient energy use on farm, will be explored in webinars later on this year. Jamie, if you could advance to the next slide, which is the agenda. We are fortunate to have really a rock star group of expert panelists today. Dr. Ermias Kebreab of the University of California, Davis, and Dr. Logan Thompson of Kansas State University are 2 of the authors of the animal protein production chapter of the report. They, along with Dr. Kim Stackhouse-Lawson, Dr. Jasmine Dillon, and Dr. John Sheehan, all of Colorado University, were authors of that particular report. Today, Drs. Kebreab and Thompson will provide a summary of the key findings. Other speakers today include Dr. Tim Kurt of Dairy Management, Inc., the National Dairy Checkoff and a longtime supporter of USFRA, and Michael Crinion, a dairy farmer in South Dakota, a board member of Edge Dairy Farmer Cooperative, and chair of USFRA. Before we get started today, we have just a couple of housekeeping announcements. The event is being recorded and will be uploaded to our website and our YouTube channel. We invite you to use the chat or the Q&A function. We'll try to answer questions in real time as best we can. We will have time at the end of our session today also to address some of the pressing questions as well. With that, I think we're going to go ahead and get started. Jamie, it's my pleasure to introduce our first speaker today, Dr. Ermias Kebreab, who's going to talk a little bit more about enteric methane mitigation strategies. Dr. Kebreab, the floor is yours.
Thank you for inviting me for this. Yes, so as part of the potential for U.S. agriculture to become greenhouse gas negative, we looked into some of the options that we have, and I'll be focusing mostly on enteric methane emissions today and some of the advancements that we've seen in this field. Next, please. Just to have a bit of a perspective, if you look at how much greenhouse gas emissions is being produced by all sectors of the economy, you'll see that it's around 60 gigatons of carbon dioxide equivalent, and the agricultural share of that is roughly about just under 20%. And if you look at the different parts within agriculture, you'll see that the majority is land use and land use change and forestry. That's we can't really do much about it for the U.S. conditions. And the next one is enteric fermentation. So about 30% of the emissions from agriculture is attributed to enteric fermentation. So I'm going to be really focused on that and what we can do to reduce enteric fermentation. And then enteric fermentation of our methane emissions is not only it has a an environmental impact, but it's also a loss of energy to the animal. So there could be a win-win kind of situation. So we'll explore that a little bit more. Next, please.
Dr. Kebreab, can I interrupt for a second?
Yeah.
You're somewhat hard to hear. Is there a way to get closer to the microphone or adjust that? Because we're having some difficulty hearing you.
Okay. Let me. Is this better?
Can you speak up a little bit more?
Okay. Is it better? Can you hear me better now?
Yes, absolutely. Yeah, when you brought it down close to your mouth, we could hear it much better. Thank you.
Okay, let me adjust it properly. Okay, great. All right, so then the FAO broke down sort of different pathways to low emission future for livestock systems. Both the demand side and supply side reductions have been estimated, and what they estimated is that from the demand side, dietary changes, if fully adopted, will have a potential of reduction about 6%, while up to 70% reduction can be achieved from the supply side. But particularly looking into the different parts. I think if you the next one will show us some of those ideas. Yeah, so breeding, rumen manipulation, feed and nutrition and improvements will have a big potential in terms of reduction of enteric fermentation. Next, please. So a series of meta-analysis was conducted to quantify the impact of adopting various mitigation practices on global temperature. This can help us meet the Paris Agreement target, but only until 2030. So we will need further reductions by 2050. This is a really active field at the moment, and there have been a lot of progress since the work that was published. So I'm going to share with you today some of the latest things that's happening in this space. We'll be looking for technologies that can be widely adopted and give us a considerable reduction in methane emissions. Although there are a lot of different strategies, let me start with the rumen manipulation, particularly with feed additives. So when you look at this feed additives here, these are basically ingredients that are given in small quantities and have impact in either inhibiting methanogenesis directly or indirectly through modifying the rumen environment. And when it comes to efficacy, it's very clear that bromoform containing seaweed or synthetic bromoform have the largest reduction in emissions, followed by fatty acids or lipids, and compounds such as 3-natoxypropanol, known as Bovaer in Europe, have shown also reliable reductions in emissions. And plant secondary compounds, particularly tannins, have also shown to be quite effective. So I'm going to talk a little bit more about those potentials that can be implemented in the US. Next, please. All right, so one of the potential is to use dietary lipids. There has been a lot of work done in this area. There's like 13 meta-analysis already done. So we've done a secondary meta-analysis. So basically a meta-analysis of all the meta-analysis that's been done on dietary lipids to try to understand what is the impact of adding lipids into the diet. And what we've looked at is that from methane production, we can have about 13% or 13-14% reduction in methane production by adding more lipids into the diet. And we wanted to have a kind of a baseline. Most diets will have lipids in them already. So we're trying to analyze if you start 2% or 3% or 4%, how much reduction can you get? Because you can't really go more than 6 or 7% in the diet. And so this is the way we try to analyze and then figure out exactly how much reduction you're going to get by additional lipids, particularly polyunsaturated lipids. Next, please. And there has been a lot of work done on Bovaer. Bovaer or 3-NOP is probably the most studied additive in the world and has been approved by most countries, including the European Union, Canada, and the US as well. And what we've seen is that about 30 to 40% reduction in dairy cattle and beef cattle.
but those were mostly done sort of a short-term trial. This was the first long-term trial that was done. This is over full lactation. We've seen that the reductions still hold for a full year. The effectiveness kind of varies a little bit, which we were predicting anyway because of the quality of the diet. So the high quality of the diet, the more effective it is. So in early lactation, you see more reduction, and then in later one and during the dry period, you see less reduction because of the quality of the diet. Next, please. And the other one that has been in this case also, we did some meta-analysis on tannins, and the key finds for this was that about 10% reduction in methane production. So using tannins, these are tannins that are added into the diet. So just adding tannins into the diet, you can have a reduction of about 10%. There could be some associated effects as well. In some cases, there is some reduction in fiber digestibility, but we haven't seen any impact on productivity. And we've seen sort of changes in how nitrogen has been excreted in the manure, and mostly changing nitrogen from urine to fecal nitrogen, which may be better for the value of the manure as well as for environmental reasons as well. Next, please. As the example of tannins, very recently we've done some work looking into adding grape hummus into the diets. And what we've seen is that adding grape hummus into diets have reduced methane emissions by about 10% or so, and also improved milk production. So if you look at the intensity, which is the amount of methane produced per kilogram of milk produced, we've seen a significant reduction in that. So these are some things that can be included into the diet. Some of the things that have not been approved yet, but there's a lot of work that's been done, is bromoform containing seaweed. So if you go to the next one. So again, we did a meta-analysis of all the work that has been done so far on seaweed, or whether it is natural or synthetic. And what we've seen is that at a mean inclusion level of about 28 milligrams per kilogram of dry matter, we've seen about 47% reduction in methane production. So it's quite substantial reduction in methane production. Similar to bovine or 3-NOP, we've also seen that the diet kind of affected. The high fiber diets, there's less efficacy, and high concentrated diets will have a better efficacy for bromoform as well. Next, please. And it really depends on how much the animals are actually consuming. So if you click one more, so we see here if the animals are actually eating the seaweed, there is a much reduction of emissions happening. So we had some palatability issue. But if the palatability issues are fixed, which can be done through flavorings and other things, that you can see that the reduction would be quite substantial. And if you go next, and we haven't seen any differences in productivity. There has been some reports that show that there was better productivity with seaweed, but in this case, because of the duration of the trial, we have not seen that productivity. But at least there was no negative effect on productivity. Next, please. And something that was quite interesting that we've done very recently was looking into seaweed alternatives. So this is synthetic bromoform that we use in the oil form and also in the powder form. And what we've seen was, if you click one, you can see that there was 95% reduction, up to 95% reduction in emissions. So it works really, really well, at least in the oil format, and I think it will also work in powder format when the formulation has been sort of clarified. And I think there's a lot of other work that's happening to make sure that the powder will be as effective as the oil as well. But in general, we've seen quite a huge effectiveness in synthetic bromoform. Next, please. Compared to nutritional strategies, genetic solutions result in long-term progress. And so they tend to be more cost-effective over time. So research with sheep, for example, in New Zealand showed a 12% reduction in emissions through breeding, and similar work is going on in dairy cattle. So preliminary results have shown that breeding animals with reduced methane emissions can result in decreased emissions about 11 to 20%. So this is a sort of a long-term solution, but this is something that's been studied right now and is very applicable to beef cattle or grazing cattle because you don't need to do any kind of addition or any additives on top of it. Once they're there, that's there, and it is cumulative over time, so it only gets better over time. Next, please. Something very innovative stuff that's happening at the moment is looking into the microbes. The microbes are the ones that are producing methane. So identifying the genes that are responsible for methanogenesis and editing the genes out to make the animals also do not produce any methane. So this is a high risk, high reward kind of thing. Theoretically, it could work, but it may not work at all. But this is something that's been explored, and also looking into the use of hydrogen, so alternative use of hydrogen. So instead of the hydrogen being used by methanogens, if we are able to promote some of the microbes that are utilizing hydrogen, then we can increase the productivity of the animals as well. So you can reduce methane emissions by reducing the substrate for methanogens. At the same time, you use that substrate to produce energy so that you have a better feed conversion ratio as well. Next, please. And finally, there's a lot of work that's been now done in vaccines. A lot of work in vitro in the lab. It has been shown that vaccines work. Now there's a few in vivo with real animals tests that have been done. Not much has been reported yet, but this is a very active area of research. There are at least 2 or 3 companies that are working on the vaccines right now, and they are in the phase where they're going to do animal trials. So I just want to mention this as you, I'm sure you will see this coming up very soon, and you're going to get about 10 to 20% reduction in methane emissions, and it can easily be part of the vaccine routine that animals are getting. And so that's you can do this, and then you can do all the other things that I have shown earlier before as well. So it's kind of stackable things. You can do vaccines 20%, and then you can do breeding 20%, and you can do other additives 30, 40%. So eventually you will be able to get over 50% reduction in enteric methane emissions. Thank you.
Wow, that is exciting, Dr. Kebreab. You know, I have just a couple of quick follow-ups, and I'm sure others may have questions. Please fill up the Q&A in the chat with your thoughts. So your data seems to show higher potential around seaweed than 3-NOP. Am I reading that correctly? Can you talk a little bit more about that?
Yes. So the seaweed and the 3-NOP kind of work in a similar way. They are both inhibitors, but the bromoform has a higher potential in terms of reducing the emissions because of the bromoform affects directly the enzymes that are responsible for methanogenesis, and it seems to last a little bit longer as well. So with 3-NOP, you probably have to do it twice a day. Is probably better than once a day. The effect seems to go quicker than the bromoform. So the bromoform lasts a few days. So even after 2-3 days, you still have that reduction. And so because it stays in the room and a little bit longer, it has a more impact in reducing methane emissions.
Got it. That's helpful. You talked about a lot of different tools in the toolbox, whether you talked about feeding, vaccines, microbiome, genetics. What are you most excited about? And really, I'd like you to look through the lens of farmers and ranchers in terms of what these tools cost, how that impacts adoption rate, et cetera. Can you talk a little bit more about that, please?
Yeah, so I'm excited about a number of things, but I mean, one of the things I'm excited about is this gene editing technology where we identify the genes and then we are able to edit that out. What it means is that, and we are able to increase the microbes that will use hydrogen, what it means is that you have reduced amount of methane, but you have increased productivity as well. So what I'm hoping to see is that the productivity gains could be enough to basically pay for the reduction of the or the introduction of the technology as well. At the same time, we have vaccines also that would be sort of easily incorporated into the system right now. We don't have to change anything. It would be just another vaccine added to the host of vaccines that animals get anyway. And I think that would really help in terms of about 20% when you have 90 million cattle in the U.S. That's a lot. So the cost, I think, there's a lot of now. The carbon market is developing. We already have a marketplace at the moment, and they've already issued $5 to $10 million in carbon credits for reducing methane emissions. So that market is maturing, and so hopefully the expense of you buying a vaccine or an additive or something like that could be covered by carbon credits.
Got it. Questions are starting to flow in via the Q&A, and maybe while Dr. Thompson is presenting, you may want to address some of those, Dr. Kebreab. But I want to ask you one from Charlotte that came in first. She was asking about any issues with bromoform being listed by the EPA as a possible human carcinogen. Do you know anything about that, or that the risk might be mitigated through ruminant consumption?
Yeah, so I think that like most chemicals, it's about the dose. How much you're giving the animals at the level that the animals are given at the moment is very, very low risk, but that work has to be done. So the toxicology reports have to be done, and there's I know that already those experiments have been done, but now they need to be published, which really shows that what's the impact of using the bromoform at the level that we are using. There's an impact on the animal health. Is there an impact on the products themselves and people consuming those products? So that kind of test needs to be done, and it's been done. So once that's available, I think those questions will be answered.
Wow, so much exciting work is happening in this space. Thank you for giving us some insight into that. So thank you, Dr. Kebreab. Our next speaker is Dr. Logan Thompson, who's with Kansas State University. Logan's predominant research is in measuring GHG emissions in grazing systems and how grazing management impacts the ecosystem function. He's going to explore a little bit more detail around manure management. Dr. Thompson, the floor is yours, please.
Yeah, thanks, Kevin, for having me on this afternoon. And yeah, that background kind of is against a little bit of the topic that I have. So manure management, manure greenhouse gas emissions, to me are one of the critical aspects of where we've broken, natural processes with modern livestock production. I think it's also a little bit underrepresented in the conversation around climate change, climate neutrality, climate negative, or carbon negative emissions, what have you. But it can be quite important given the right production system and the right livestock species. And to highlight that, I pulled this figure out of a publication of ours from a few years ago. This figure here shows EPA emissions from 1990 to 2020, looking at enteric methane and manure methane emissions. And you have beef on the left-hand side of the screen and dairy right next to it. And what we've seen is beef cattle enteric emissions, they've responded quite naturally to changes in cattle populations, as one might expect, right? And manure has remained relatively static. But dairy manure emissions, manure methane emissions have been rising quite drastically over the last 30 years. There's reasons behind that, and I'll go into some of those. But it's getting close to being being equivalent to dairy enteric methane emissions. When we first plotted that out, I was quite surprised. But when you think about the changes in the industry over time, it kind of makes a little bit of sense. So you think, confined systems and changing manure handling practices, they've all played a role in dairy manure becoming more important contributors to greenhouse gases. And so I thought I'd just highlight some of the recent trends in the last handful of decades here in U.S. beef and dairy cattle production. So one, we've seen a shift from, smaller mom and pop, as I think of it, production systems, into larger and larger confined feeding operations. That's changed how we're handling our manure. So less dry manure storage, more liquid manure handling, changing times before we get rid of that manure or apply it into fields. We've also seen a shift in diet compositions that we're feeding the animals. The one that always jumps out to me is, mid 2000s, we started to see a pretty drastic increase in the amount of distillers that are being fed to confined cattle. Right, that is an important source of protein, and thereby it impacts our excreted nitrogen profile. It also impacts our fecal carbohydrate fractions as well, and can also potentially increase manure methane emissions from that standpoint, as well as the nitrogen standpoint. And I hit on it already, but increased liquid manure holding at the expense of dry lots. This creates microenvironments in those lagoons that favor methane production, and we're retaining that manure longer. As in some regions, it's getting harder to offload manure. I was on a call not too long ago with a dairy producer down in the Texas Panhandle, and he was telling me how hard it is for them to get rid of manure, because a lot of their fields now are the nitrogen and phos balances are at a place where it doesn't need more manure, right? So how do you offload that efficiently, and how do you get it into crop ground that needs the nutrient profile that their manure has? Right? And I know some guys are just giving it away. Other regions, it's a profitable endeavor to get rid of it. So it's very regionally specific. And then on the beef cattle side of things, you can maybe see this in the picture on the right-hand side. We're also feeding cattle to heavier endpoints. Right? These are beef cattle heifers that were finished out this past winter in Southwest Kansas. I think that pin averaged around 1,625 pounds when they were processed. So that's a relatively inefficient endpoint. So we're feeding different diets. We're changing how we're handling manure, and we're changing when we're marketing those animals, how long we're handling their manure. It all adds up to increase manure greenhouse gas emissions and increased manure that we have to deal with. So I also want to tie this back into what Dr. Kebreab talked about. Where do we start and why do we care? Enteric methane is the low-hanging fruit. Admittedly, that is what keeps my lab's lights on most of the time. It is a significant contributor of our carbon footprint. This figure here is from Rotz et al. In 2019, a breakdown of U.S. beef greenhouse gas emissions. Enteric methane predominantly coming from grazing cattle, not confined cattle. That drives our footprint. But manure greenhouse gas comes in the form of nitrous oxide and methane emissions. So it's a smaller yet slightly more complicated emission source. And I also wanted to highlight on the right-hand side of the screen, you can see for the United States, this is U.S. nitrous oxide emissions published this past year. Agriculture is responsible for 79% of nitrous oxide emissions in the United States. Manure is going to be around 17% of that total. So that's going to be both direct emissions from manure and field application of that manure. So for that greenhouse gas, it is a relatively important contributor to the country's overall nitrous oxide emissions. And so while it is small, it's slightly more complicated and still relatively important with that specific gas species. And then to add to the complexity of manure greenhouse gas emissions, it's incredibly variable, right? Depending on where you are in the country, what your operation looks like, the diet that you're on, right? Diet can vary widely. It's highly, highly variable. And one way I like to contextualize this is when I think about enteric methane emissions, if I know the diet that the animal's on, the physiological status of that animal, and the growth production potential of that animal, I can probably get somewhere close to where methane is, just predicting it out. With manure, it's much harder to do that. That's because we don't really have great tools to measure manure gas fluxes. So this figure here is an experiment that we did using static chambers. This was the historic way of measuring gas flux on soil on pen surfaces. But you look at all those chamber bases in this picture, if I were to put the exact same manure profile in each one of those chambers, they're most likely all going to have different gas flux amount, just depending on the microenvironment at that aspect of the pen. Right? They're all different. And our micrometeorological techniques like a eddy covariance system or a dual comb system that can measure larger and larger areas, they're just not to a spot yet where we can apply them at a production level and get a better understanding of what our gas flux looks like on an open lot surface. And I often see it in the literature, you know, people will take point source measurements at confined feeding operations and they'll say, look, this is your manure methane production. And really that's what they're finding is the lagoon methane production, because that's the largest plume of manure of methane that's going to happen. And that's the easiest one for them to detect. What's happening on these open lot surfaces is relatively small and harder to get a real firm grasp on what the numbers actually look like. And also with manure, nitrous oxide, that's the greenhouse gas, but nitrogen is what I like to think of as a nasty element. And once it's excreted out of the animal, whether it's through urine or feces, it can take a lot of different forms and it can have impacts on the ecosystem or the environment in a variety of ways. Some we can see and some we can't, like greenhouse gas emissions. But it can cause eutrophication of water systems, so harm aquatic life and also human health impacts there. It can increase cases colorectal cancer, blue baby syndrome, or respiratory illnesses. So I think of smog production, you know, PM 2.5. If anybody listening has been out to the High Plains region or Southwest Kansas, Eastern Colorado, and you come across a large feeding operation, whether it's a dairy or a feedlot, you'll notice that there's traditionally a haze at the right time of year over the facility, and that's some of that particulate matter that's being produced in part from manure. And then also wet and dry nitrogen deposition in sensitive ecosystems. This causes a lot of concerns with stakeholders outside of greenhouse gases. And the example that I provided here is this figures from Brandini et al. In 2023, but it walks through nitrogen deposition in the Rocky Mountain National Park in the Front Range of Colorado. Maybe 20, 30 years ago, this became a concern for stakeholders in the Front Range because they started noticing negative ecological impacts in the Rocky Mountain National Park. And they figured out that part of that nitrogen was coming from confined feeding operations on the Front Range. And when conditions were right, nitrogen would catch an updraft and go into the mountains, be deposited there at the park. And it created a good thing. We, you know, developed, our CSU developed an emergency alert system when conditions are right, so people could try to mitigate nitrogen going into the mountains. But it's just another example of manure emissions. It's a larger conversation rather than just greenhouse gases. And the last part I'll touch on before I talk a little bit about mitigation strategies. Since this report was authored, and Dr. Kebreab could maybe correct me, but it's been a handful of years since we sat down and wrote this chapter. But methane accounting has seen a little bit of a shift in terms of how people are trying to go about it. Traditionally, we use what we call global warming potentials on a 100-year time horizon to calculate greenhouse gas emissions relative to a CO2 equivalent baseline. And in the past few years, there's been more and more exploration of a metric called GWP star. The GWP star is a time-sensitive or rate change metric that more aptly captures the behavior of methane in the atmosphere. It's a short-lived greenhouse gas, maybe 9 to 12 years in the atmosphere. Carbon dioxide is a millennia gas. It's effectively there until it's not. And with this new metric, it's caused us on the accounting side to think of, you know, what does this mean for methane emissions from the industry? Like, does this change our perspective on what's important or what's not important? So from that first figure I showed you, we took the same EPA US greenhouse gas emissions numbers and looked at it from a GWP 100 basis or a GWP star basis. So this table here breaks down 2010 to 2020 for beef and dairy. But I just want you to focus in on what I have boxed in there on the top right. That's manure emissions for beef and dairy, GWP 100 and GWP star. You can see for beef, It's a relatively small number, GWP 100, relatively inconsequential change with GWP star. It makes sense. Enteric methane emissions drives our footprint, right? For dairy, I mentioned already there's been a significant rate change in manure methane emissions. We actually see dairy manure methane using GWP star now being a larger contributor to warming than enteric methane emissions, which is not something that we expected because we just hadn't looked at the metric in this way before, but it does make sense. We are generating more methane quicker than we used to. With that significant of a rate change, that does add up, right, in terms of a cumulative warming impact. And I know it's a little bit of, well, we can't really measure it, so what do we do for it? But I think this should be exciting, right? Because we do have management strategies in California where Dr. Kebreab is based. There's a really good one in anaerobic digesters, but we do have strategies in place. We do have things we know can work. So I have a few of them listed out here. On the animal-based side, for beef cattle, I think of reducing dietary protein. For feedlot finishing steers today, it is extremely common to overfeed protein in the diet. 16, 17% crude protein is not abnormal, even though steers requirements may be around 11.5, 12% crude protein. It's done that way for economic considerations more than anything. But we have had research out of University of Nebraska and some other locations that have more aptly phase-fed protein to meet finishing steers requirements. And we've seen a 15 to 33% reduction in those studies in volatile nitrogen excretion. And that volatile nitrogen is a precursor to ammonia and particulate formation in the atmosphere. We also have dietary tannin inclusion, which Dr. Kebreab talked about already. This can work for both enteric and manure because tannins bind protein in the rumen. They shift fermentation there and then also further into the gastrointestinal tract. And as he mentioned, and more importantly, they shift nitrogen deposition, hopefully, from urine to feces. If nitrogen is deposited in the urine, it's almost immediately volatilized. Large percentages of it are volatilizers right away. If it's deposited in the feces, it's a more stable form, right? And it's less likely to be lost in that form. So anything we can do to shift it is quite important. And Brandini et al. In 2023 reported anywhere from 17 to 15% reduction in urinary ammonia concentrations when including tannins. And then on the management side, things that a lot of crop producers and integrated crop livestock producers know all too well. That's just proper manure handling, right? Proper application of manure onto fields, like when you time that up in the season. When do you inject? So maybe you inject more in the summer months because the soil's hot. If you inject it, you're going to keep more of that nitrogen, more of that organic matter bound and allow it to be utilized by the crops. Don't apply it in the wintertime when soil is frozen. It's not going to be incorporated and will just be lost. Just best management practices that we all know can all serve to reduce emission rates once that manure has been applied to the field. And then I think the most exciting thing for me is anaerobic digesters. Admittedly, there's not too many of them in Kansas, but there are some. I saw one not too long ago. But anaerobic digesters are a really promising tool to reduce emissions, depending on adoption rates and where you are, climatically. That impacts what kind of digester is going to work for you. But you can see greenhouse gas emission reductions over 50%. And then you also get the benefit of providing renewable energy, most commonly into the California green energy program. Right, so maybe get some financial compensation and reduce greenhouse gas footprint. That to me, that's exciting because I want to see when and how it gets applied into the beef sector. Right, we're seeing it be effective in dairy cattle, and Dr. Mitloner at UC Davis has published on this several times in the last few years. But in I think it was December of 2024. There was a big feedlot operation in Nebraska announced that Adams Landing Cattle announced they were going to install a digester and go to graded concrete flooring, right? Expand capacity to 150,000 head, I think is what the announcement was. I think we'll all be paying very close attention to how that program works, right? Because they're probably going to reduce mud impacts, which might improve animal productivity. And how effective is this digester, in terms of them feeding a digester enough substrate? Because when I think open lot feedlot systems, it's a little bit of how is a digester going to work with open lots, because they're just so much different than a dairy cattle operation. So as those expand into beef, I'm sure that's going to cause more and more changes to how we handle our daily operations. But I think it's exciting because it's like this is a tailor-made solution. It just needs to become more economically advantageous and get more and more early adopters. And then one more kind of double win strategy. I mentioned tannins because I knew Dr. Kebreab was going to talk about it. But one that my lab group has been looking at and is publishing and is getting some additional work out is a limit feeding. So methane emissions, enteric methane, we know primarily driven by level of intake. And a lot of our growing beef cattle producers, so backgrounding producers, they already limit feed those cattle in some form or fashion. And so we were trying to figure out how that strategy could work for both enteric and manure emissions at the same time. Because theoretically, if you're reducing inputs into the animal, you're going to have to be reducing outputs, right? And what our results have shown is that a modest around 4% reduction in dry matter intake, so voluntary dry matter intake, has not negatively impacted animal performance. Actually, we're seeing, in most cases, small improvements in animal efficiency with reductions in dry matter intake. That normally tends to disappear after around a 92% reduction in 92% intake relative to ad libitum. But it reduces enteric methane, which you can see on the top right under enteric emissions. And below that, you see manure emissions. Restricted fed animals are commonly coming in with fewer greenhouse gas emissions, both methane and nitrous oxide, when they're limit fed. So can maybe work both directions, and is already something that a lot of our industry is comfortable with in one form or another, right? The only downside to this is you might see modest decreases in carcass quality, right? So there still needs to be work there over how we can overcome this. Although we have some studies in the works to figure out if timing of implants can help work around that marbling issue that we're having. And just to highlight one last time, strategies that work for both enteric and manure emissions are going to be required. Dr. Kebreab talked about genetics. That's going to be a wonderful addition to the portfolio of greenhouse gas mitigation strategies, because we have a long way to go. So from the same Rods et al. In 2019 paper, if we're going to be climate negative, we have 243 teragrams of carbon dioxide equivalent emissions to offset, avoid, or remove in one form or fashion, right? So it's going to take all of us working in a lot of areas in order to accomplish this task. But the good thing is, it seems like a lot of the industry is all rowing the boat in the same direction, which feels unique for me. I'm not used to the beef industry all rowing in the same direction, but it seems like there's a lot of folks across the states working on this. So I'm sure we'll be able to get it done. And with that, I'll thank you all for the time.
Thank you, Dr. Thompson. I tell you what, it's been enlightening to me to hear all about the innovations and developments that are happening in this space. It is truly an exciting time. Certainly many challenges, but I think we are working on those. Dr. Thompson, I'm hoping you can stay for the Q&A. I'm not going to ask any follow-ups at this stage because we're running a little bit behind. So hopefully you'll be able to stay there. But I'd like to introduce our next speaker, who is Dr. Tim Kurt. Tim is a Senior Vice President of Environmental Research at Dairy Management, Inc. Unfortunately, Tim couldn't be here today live, but he did take the time to pre-record his presentation, which provides an overview of DMI's important work in this area. Jamie, can you roll Tim's video, please?
Greetings. It's an honor to join fellow panelists Ermias Kebreab, Logan Thompson, and Michael Crinion in this webinar on USFRA's report on the potential for U.S. agriculture to be greenhouse gas negative. My name is Tim Kurt, and I'm Senior Vice President for Environmental Research Strategy and Group Lead for Environmental Research at Dairy Management, Inc., the National Dairy Checkoff, and the Innovation Center for U.S. Dairy. And I'm pleased to share some of our work with you today as it relates to greenhouse gas neutrality, which, as you may know, is one of U.S. Dairy's 2050 environmental stewardship goals. I'm going to give a brief overview of the presentation here, which will involve sharing some of our overarching strategies, a little bit about our measurement and modeling work as it relates to greenhouse gas emissions, and that includes our 2020 life cycle assessments, our strategic roadmap to GHG neutrality, the ruminant farm systems model, sustainable manure management impacts tool, or SUMMIT, as well as a new research program related to animal health, efficiency, and resource dynamics, or HERD initiative. A quick note that research sponsored by Dairy Management, Inc. and the Innovation Center for U.S. Dairy is funded by America's dairy farmers, and certain research activities are ineligible to be funded by the checkoff, in which cases those programs are partially funded by other sources. The checkoff's mission is to build trust in sales of U.S. dairy products, and one of the ways that we do that is through demonstrated commitment to environmental progress. Our overarching strategies for how to do so involve a number of different areas, including measurement and modeling, environmental research, and partnerships in environmental stewardship. In the measurement and modeling space, we conduct a number of different projects to inform the industry and support the industry by providing credible, unbiased information, as well as demonstrating continued commitment and progress in responsible production. Our environmental research is conducted in collaboration with external scientists to address knowledge gaps and support the development and evaluation of new practices and technologies. And we also have a number of partnerships and projects in the environmental stewardship space that are aimed at better understanding the barriers to implementation and addressing those through enhancing access to financial and technical resources. Across all of these, we incorporate economic feasibility and make sure that all these projects benefit or potentially benefit our farmer stakeholders. I'm going to first focus on our measurement and modeling efforts, which span from industry-wide down to the level of individual farms. Some examples of the industry-wide projects or national level projects are our 2020 life cycle assessments and the strategic roadmap to GHG neutrality. At a regional level, we have projects such as the Sustainable Manure Management Impacts Tool, and at the individual farm level, we have projects such as the Ruminant Farm Systems or RUFUS model. Our 2020 life cycle assessments focus on greenhouse gas emissions. And the reason why we're doing new life cycle assessments is because the science, methods, metrics, and reporting guidances have changed since the industry's last published LCA circa 2008. And so we've conducted this analysis in collaboration with Dr. Riley Pelton at LAIF to better understand the contributors to the dairy industry's greenhouse gas emissions footprint on a national level and to help inform potential mitigation strategies. This work will also set the baseline for measuring progress, which the industry has committed to report on every 5 years starting in 2025, as well as for modeling different scenarios towards the 2050 GHG neutrality goal, and that will be part of the strategic roadmap, which is also planned for release in 2025. When we look at the results of the LCA analysis, we see we learn a number of different things from this process. So if we look at the left, we often refer to this graphic as our farm print graphic, and what it aims to do is to show where the majority of greenhouse gas emissions are occurring within the farm footprint. And so all of these are relative percentages that add up to 100, and we can see with this updated methodology that the different portions of the footprint, the different sources, constitute different amounts of that total percent. So feed production in this analysis constitutes about 49% of the footprint, whereas enteric methane, which is the greenhouse gas that's associated with the normal digestive process in ruminants, is about 27% of the footprint. Energy is approximately 5%, and manure emissions are associated with about 19%. There's a variety of reasons for why these different sources constitute the relative percents that they do, I won't go into great detail, but this has been published in a journal called Environmental Science and Technology Letters, where you can look for more information. I will highlight that there's about a 1% reduction in cradle-to-farm gate emissions from carbon sequestration through practices like cover cropping and no-till. And there's also a 0.3% reduction of the cradle-to-farm gate emissions that occurs through anaerobic digestion's production of biogas, displacing energy on our grid in the US. When we look at the different types of greenhouse gases that are present at the dairy from the cradle to the farm gate, we see that the biogenic methane is the predominant gas type at 41%. And that's no surprise because of the biogenic methane from enteric fermentation or enteric methane and from manure. That has long been the primary greenhouse gas type within the dairy industry. This analysis revealed also a fairly substantial portion of the greenhouse gases are what we call aggregate CO2 equivalents, which is made up of nitrous oxide and carbon dioxide, and is primarily associated with feed production, as well as with nitrous oxide emissions themselves, associated again with feed production. What's different in this case from previous versions is that we have the inclusion of land use change, or LUC, at approximately 10% of the gas. And then we have a small portion of gases that are associated with fossil fuels, such as fossil CO2 and fossil methane. So again, when it comes to strategizing where we see opportunities for impact and progress, these types of results are extremely informative. And you can go to the journal Environmental Science and Technology Letters to learn more. As part of this analysis, we also did a retrospective assessment using the same assumptions and methods, where we tried to go back to the year approximately 2007 and look at what the changes are between 2007 and 2020. And what we saw was that the greenhouse gas emissions intensity, which is the amount of GHGs per unit of product, decreased about 13% during that time period, which is fairly significant. Particularly notable is that during that same period, fluid milk production increased an impressive 28%, and total emissions increased only about 10%. So what does this tell us? It shows us that U.S. dairy continues to deliver a high-quality, nutritious product while significantly enhancing our resource use efficiency, while making demonstrable environmental progress. This work is also important to the strategic roadmap to GHG neutrality. I mentioned that that is one of our 2050 environmental stewardship goals. We are in the process of developing a report that will estimate the potential total greenhouse gas emissions reductions that could be achieved at a national scale using the best available scientifically valid practices and technologies under a variety of different scenarios. We're leveraging that 2020 LCA. We have both the cradle to farm gate and then a processor level LCA that's in progress to establish the emissions baseline for this modeling effort. And we'll incorporate an economic feasibility assessment around the different technologies and practices to better understand the barriers to implementation and the investment needed for impact at a national scale. All of this to say that it will inform the development of GHG mitigation strategies and help identify areas where further research and development are needed to help close any remaining unmitigated emissions. At a regional level, we have a tool that's just been released called the Sustainable Manure Management Impacts Tool, or SUMMIT. I won't go into this in great detail, but you can scan the QR code on your slide to go to the website to learn more. This is freely available. It's been designed to be a user-friendly tool that helps users evaluate greenhouse gas mitigation strategies for manure management across the U.S. It enables regional scale GHG analysis using customizable scenarios and expert-informed defaults for 10 different manure management technologies. And it is constructed in a way that reflects the variety of different dairy farm configurations that are present across the United States. So please go check that out. There is a user manual associated, and I think you'll find this to be a really interesting and useful tool. This, again, is consistent with our efforts to better understand and model at a regional level. At an individual level, a lot of our effort has gone into supporting the development of the Ruminant Farm Systems Model, or RUFUS, which is a collaborative effort among researchers at a variety of institutions, including the USDA, Cornell, and several other institutions. RUFUS is a whole farm process-based model that simulates dairy farm production and environmental impacts starting with individual cows. It identifies ways to improve efficiency and sustainability, and it has a range of applications from being a research tool for scientists to a decision support tool for the industry, and even feeds into some of the reporting tools that the industry is using, which I'll touch on the next slide. Importantly, RUFUS is very transparent and thorough in its documentation, and accessible as well. So it will be published as open source code, and it can be updated with additional iterations, for instance, including financial modeling, which we plan to do in the future. So I mentioned that RUFUS also can power industry level reporting, which it is doing through the Farm Environmental Stewardship Program. So FarmES is a program of National Milk Producers Federation, or NMPF, and it's a farm level environmental assessment and customer assurance program that provides comprehensive estimates of greenhouse gas emissions at the farm level. And since October 2024, FarmES version 3 has actually been powered by the RUFUS model. So unlike many reporting programs, it actually runs this process-based model to come up with a carbon footprint for that operation using actual farm data. What's really interesting is that it then enables farmers and farm advisors to run what-if scenario analyses that can highlight some of the potential opportunities both for their business as well as for the environment. To date, over 180 evaluators have been certified for using version 3 of FarmES, and there's been over 215 version 3 evaluations across 21 states in the US. Amongst the types of scenarios that have been analyzed, we've seen folks trying out different feed additives, as well as trying to understand the impact of different manure management changes on their footprint and on their business. I'm now going to shift to describe a little bit about our research. So just at a high level, we have a number of different large-scale research initiatives that have been developed to address some of the opportunities that you saw in the previous slides. I mentioned enteric methane mitigation. There's a program called the Greener Cattle Initiative that supports research to enable enteric methane mitigation. Also mentioned the emissions associated with feed production. We have another large project called the Dairy Soil and Water Regeneration Project, or DSWR, which seeks to better understand the effects of different practices like cover cropping and no-till and the use of manure products on carbon sequestration and greenhouse gas emissions fluxes in feed production. We have some other work on manure products as well coming, and we'll have more information on that coming soon. But I wanted to talk a little bit about our new initiative on animal health efficiency and resource dynamics called HERD. For all of these, you can scan the QR codes to learn more about these initiatives. But first, our Dairy Herd Efficiency and Resource Dynamics, or HERD initiative, was created because animal health is a top priority for both producers and for the public. However, there's virtually no US-based research that examines the impact of animal health on sustainable dairy production. So the goals of this program, which I should mention, the partners on this are DMI, the Foundation for Food and Agriculture Research, and Zoetis. The goals of this program are to quantify the positive impacts of animal health and herd efficiency on the environment, to assess potential environmental economics of improved animal health, and then to integrate those results with existing models and decision support tools. There's currently approximately $1.3 million available for this research initiative. And so I encourage you to share this with your networks. Applicants can apply for research funds at foundationfar.org. Finally, in our partnerships and stewardship area, we do quite a bit of work to enhance access to financial and technical resources. And I wanted to point out one unique resource in that space, which is the Dairy Conservation Navigator. You can find this resource at dairyconservation.org. All of the resources are publicly available and free to use. This has been informed by over 70 experts. There's a number of different courses that can be taken through the Learning Hub. There's over 80 practices and technologies that are featured in a searchable database that can give you information about what sorts of environmental benefits are associated with different practices and technologies, as well as some idea of what their capital investment and operating costs and complexity are. So it's really an incredible, very comprehensive learning center and hub of information that I encourage you all to go and check out. So in summary, I think we can conclude that sustainability is a foundation for building trust. And from our perspective in the dairy industry, measurement and modeling, research and partnerships and education are key to supporting the industry in their efforts, as well as to demonstrating continued commitment and environmental progress. With that, I thank you for your patience and attention, and thank you for the opportunity to share a little bit more about this work. I know I'm not available for questions during this webinar, but I'd be happy to take questions at a later date. If you contact Kevin, I'm sure he'll give you my contact information. Thank you very much.
Thank you, Tim. And yes, if you do have questions for Tim, feel free to funnel those through me, and I will make sure that we get answers to you. Lauren in the chat has included a link to the herd funding opportunity that Tim had mentioned. So feel free to learn more there. It is exciting to hear all the great work that DMI is doing in this space when you talk about the measurement and the modeling, the research that they're supporting, and the tools that they're providing for the dairy industry. It's impressive, and every time I hear Tim present, I'm more and more impressed with the work that's being done there. So thank you very much, Tim. Our last speaker today is Michael Crinion. Michael is a dairy farmer in South Dakota. And as you will hear from his accent, Michael is not originally from South Dakota. He's a proud Irishman, but he has lived in the U.S. for more than 20 years. He's going to tell us a little bit more about his dairy farm. He does have an anaerobic digester, and as Dr. Thompson had mentioned, that's a tool that he's really excited about personally, but Michael will talk about that and share a little bit more about his operation. Michael, please go ahead.
All right. Thank you very much, Kevin, and thanks for inviting me on the panel here today. I've learned a lot from the three previous speakers, a lot of good information. Our dairy farm, we've got, it's a 2,100 cow dairy operation, and it's just east of Brookings in South Dakota. And we do have an anaerobic digester, and it is producing gas, and it is through a virtual pipeline going into the gas pipeline that feeds all the way to California. And we get a percentage of the gross revenue off that. We would like to see the LCFS a lot higher than what it is. When we originally put it in, the LCFS was at just over $200 a ton, and now it's either side of $50 a ton. But it's good. It definitely has helped reduce odor on the farm, and the crop farmers that get the manure off us have talked about the manure being very much homogenic in the, and so it seems that we get a better application to the crop farms, and everybody's happy with that. What I have liked on some of what I've been learning this morning is, or this afternoon, was, you know, all the new technology that's coming down, be it from vaccines, be it the possibilities of seaweed, Bovaer, and you know, I've even heard of some stuff on biologicals that you can add to the feed and that as well, that will reduce enteric methane. And so, yeah, it's there are a lot of exciting things happening. Our dairy farm is a 100% Holstein operation. We have a rolling herd average of around about 90 pounds. I'd like to see it a little bit higher, but we'll keep working on that, you know. And but that's pretty much it. We sit on a site of 55 acres, and all our crops we buy in from local farmers, most of them predominantly within a 5-mile radius of the dairy. And they grow corn silage, winter rye, alfalfa for us. So.
Michael, thank you for that. Can you talk a little bit more? I know you not too long ago received your carbon intensity score for your
Yes.
operation. Can you talk a little bit more about how you got that and what knowing that information is, how you're changing, if at all, how you're incorporating that into your strategies moving forward?
Yeah, well, how we did it was with Farmers for Sustainable Food, which is part of the Edge Dairy Cooperative, and they used the Climate Smart grant to help farmers calculate what their CI score was. And the industry average for dairy cows here in the US is approximately 1.0. So for every pound of fat and protein corrected milk, you'll create about 1 pound of CO2 equivalent producing that. Our score came in at 0.81. So, which we were surprisingly surprised about it. We didn't know what to expect. And but with that, what it did show was that we had saved approximately 3,400 tons of carbon last year between ourselves and the crop farmers that are growing the feed for us. So what that has opened up is, well, how can we market that? Is there a way to market that reduction in carbon? And is there people that are willing to pay a good price for it? You know, we look at the likes of Microsoft and Meta paying $100 a ton for carbon in the offset model. Can we do the same in inset within the food chain? So there are some of the things that we're actively investigating at the moment. And hopefully the carbon market can be another revenue source for farmers, because we are the ones that are reducing we have the possibility to reduce carbon and reduce our carbon footprint.
Got it. Based on the data we've seen, feed inputs, animal feed is a significant part of the footprint.
Yeah.
How are you working with your local farmers on improvements in that area?
Well, the farmers are the ones that, the crop farmers, they're the ones that know their fields the best. And, some of them are doing strip till, some are doing no-till, cover crops. It's, every field is different. And we leave it up to them to figure out what is best for them. And then if they can sequester more carbon, well, it's a better revenue source for them as well. And the amount of carbon you'll sequester every year will depend on what your production is like. We were earlier on this year, we were looking like we were going to be having a drought this year, so to be decreased yields. Now we've got some nice timely rains, so hopefully we'll have average or maybe even above average growth, which will help the crop farmers then,
Mm-hmm. Yeah, absolutely. The digester. Take us through what made you decide that that's a route you wanted to go. Obviously, there are limitations in terms of resources and size of operations that can afford that. But walk us through the decision that you made to go that route with an anaerobic digester.
Well, the company that we're working with, we knew a number of people in that. They approached us, and yes, could it show another revenue source? All right, but is there another way to help protect the environment as well? And we do like you know, if we can be on the cutting edge without being on the bleeding edge, you know. And so they brought all the revenue to build the project. Then we get a percentage of the gross revenue, and we did help them get the permits and all of that. So the way what happens is we scrape the manure out of the barn 3 times a day. Then within 20 minutes, that's in the digester. And then there's it stays in the digester tank on average about 24 days. It's heated up to approximately 100 degrees. And they have a gentle mixer in that to keep it very homogenized. And the gas will bubble up to the top. They capture the gas. It's about 60 to 65% methane, and they clean that gas up to 99.5% methane, then put it in semi-trailers or virtual pipeline and bring it then to inject into the pipeline at Brookings. The digest aid is then pumped into our lagoon, and it's a very consistent product. It's interesting, a little bit different in color, but very sort of earthy smell to it. And you know, as the farmers they've liked how uniform as it's been applied across the fields. They don't see any difference right across the field where it has been applied.
Mhm. Thank you for that. You know, farmers like to learn from other farmers. That's where some of the best learning happens.
Mm.
For those farmers and ranchers that may be on the line today and hear this recording later, do you have any advice for them on the journey so far that you've taken, and key learnings that you may like to share with them?
You know, always be on the lookout for, you know, there's some really good opportunities out there. Even when you sign up to something, it doesn't always go right day one. It takes a while to, you know, no different to starting up a dairy barn or a beef barn. There's always a few kinks to work out of the system, but if everybody is working in the same direction, it goes a lot easier.
Got it. That's helpful. I'd like to just open it up to questions now, and a couple have come in for all the panelists, and one actually, Logan, that I'd like to ask you that came from Michael. He's talking about you know, beef cattle, you know, more and more beef coming from the dairy industry, and how that compares in terms of methane mitigation strategies compared to cow calf. Like what impact is dairy beef having on some of these mitigation strategies?
Yeah, I responded to Michael's question and said the results were enlightening, but they scared me because I'm a beef guy. But my brother runs a dairy calf ranch, so maybe I'll be okay either way. What we took a few years of data, and we're gearing up to submit this summer. Took a couple years of data on dairy beef cross cattle that were fed as calf feds, which for producers probably death loss is what you would think on those calves, or put through a stocker program and then finished afterwards. And they were compared with straight beef contemporaries. And emissions just on the calves themselves were fairly comparable. I would say it was due to inefficiency in grazing, and then also death loss as well. But when we included the cow emissions, the dairy beef cross was around 50% of the final footprint of the native beef, and that's pretty much due to the dam emissions, right? So we allocated the cow's emissions based off of basically feed nutrient requirements to support lactation versus a calf was how we allocated it. So it was interesting for sure. And I think it's a pretty important part of the industry. It's obviously growing to your point. It always kind of amazes me. I think more importantly, though, on those calves, outside of the carbon footprint, it's just like those crossbred calves eat a lot differently than we think they do. And so how can we like bring the floor up on those calves and get more of them to hit market? It will be very interesting. I think that's kind of the next frontier on those, because we definitely on the beef side have some challenges with those crossbreds.
Absolutely. You talked a little bit in your presentation, Dr. Thompson, about strategies that work on both sources, enteric and manure. And you mentioned, limit feeding, genetics, etc. What excites you so much about that particular area?
Oh, I like win-win scenarios. And Michael kind of pointed to some of that. He hit on one that was really good that I wish I would have. But the effluent coming out of a digester is like it's pretty darn consistent, right? And that's a huge issue for producers. Manure effluent is like straight manure scraped off a pin is relatively inconsistent and not what we need. To me, that's a win-win, right? Anything we can do to improve the economics and limit headaches for producers are strategies worth investing in. And I like to tell people, I'm not the smartest guy in the world, but I do come from a production background. So I think we try to keep our research pretty focused in on that, stay pretty grounded in reality.
Yeah, got it. That's helpful. Dr. Kebreab, I think you're still there, but I'd like to ask you a question if I could. Any advice to farmers and ranchers? Everyone is kind of in a different place in their journey in this area. I am amazed, and I work in this area, about all the work and advancements and innovation that are underway. But any advice to farmers and growers that and ranchers that you think would be helpful for them to have at this stage?
Yes, I think in terms of the enteric.
We're having difficulty with your audio again. Sorry.
I'm sorry.
No.
Is it better now?
Now it is. Yes.
Okay. All right. Yeah. Sorry. I think a lot of the solutions we have right now are starting to ramp up. So what I'm hoping to see is that at least the carbon market is going to get more developed, and there will be more opportunities for people to participate in this way, because some of the solutions we have, they may be too expensive to just do it by yourself, but what I see a market developing, that people who would sort of integrate and who would really come out and help farmers to be able to participate in this. But until then, I think doing it individually might be a little bit difficult, and it just adds to a lot of things that farmers are already doing. But I think there would be opportunity, like people coming in, like installing the anaerobic digesters and all that. I think similar to that, there would be also for enteric emission as well. So people would aggregate some projects that would be able to implement on behalf of farmers, and so that they don't have to spend all that time, but still benefit from doing the reduction work that would be available and that's coming online.
Got it. That's helpful. Michael, I know you are passionate about making sure that when we talk about sustainability, it's about farmer sustainability first, right? Farmers and ranchers are helping to solve some of the world's greatest challenges, and they are also running a business. How do you balance that, the need to make a profit and feed your family and send your kids to school, and yet also do right by the planet?
Well, all farmers that I know of always want to leave their operation better than they received it. But there is a lot of opportunities for farmers to sequester a lot of carbon, but they have to be properly compensated for that. And so all types of sustainability has to start with financial sustainability for the farmer first. And we've seen where people did a lot of publicity, and they were going to help fix climate change and that, but they were offering farmers maybe $5 or $6 an acre. Well, you know, that wasn't going to push the needle for farmers. And so they have to be treated as, you know, a key cog in the whole operation. We all have to work together, but farmers have to be, looked after. So there's, and then everybody else down the chain can participate then as well.
Yeah, absolutely. Well said. I want to thank you, Dr. Kebreab, Dr. Thompson, Dr. Kurt, and Michael for being a part of our panel today. I think it's an exciting area when you talk about animal protein production. It's a critical part of the U.S. and the global food chain. We're creating high quality food from low quality feed in many cases. In many cases, that feed cannot be digested by people. And so we're helping feed the hungry. I think we are going to continue this webinar series after a bit of a summer break. We're going to after the summer vacation season, so we don't have our next webinar scheduled just yet. But I want to thank everyone for participating today. We will be sending out a recording of the webinar along with the slides from the speakers. So if you did register for the webinar, we'll be sending that out after the fact. And again, if you have any questions for Tim that I can get to him, feel free to reach out to me directly. Thanks to our panelists again, and thanks to everyone for attending. Have a good rest of your day.